Hey guys, this is part 2 of 2 in our video series about finding the area of a polygon. In the first part, we reviewed how to find the area of quadrilaterals and triangles, and in the second part, we're going to apply that knowledge to find the area of more complex polygons. Let's begin. First thing we need to do is come up with a strategy. You should know that there is more than one strategy in order to solve this. I'll show you a second one actually after this. But for this one, I think the easiest strategy is to use subtraction. So what I'm going to do is I'm going to find the area of this whole rectangle, because let's say this triangle wasn't missing. You could see that it forms a rectangle, the whole thing. And what I'm going to do is I'm going to remove this triangle from it. I'm going to subtract this red triangle from it. So I'm going to find the area of the whole thing and subtract the red triangle from it. So let's fill out the information we know. We know it is 12 feet wide because it says so at the top and the bottom. And how tall is it? Well, it's obvious that it's 22. Some of you may have gotten confused and thought, what about the 12? The 12 only refers to this segment right here. It doesn't include this missing segment over there. So the height of the whole rectangle is 22. The area of a rectangle is base times height, which means it's 12 times 22. And our answer is 264. So that's the area of the whole thing, which includes the triangle. Now we want to find the area of just the orange part, not including this red part. So we need to subtract the area of this triangle. And we know that it is 8 feet tall, but we don't know what the base is. So this piece right here is unknown. We're not quite sure. Now, how do we figure it out? We've got a couple clues. We know that this whole thing, whole side right here, is 22 feet. We know that because this whole side is 22. So I'm going to use some algebra. You may be able to do it in your head and figure it out, but I'm going to show you how to do it algebraically. So we know that this piece right here, this 12 feet piece, plus this missing piece is going to equal 22, because this plus that is going to equal this whole thing. So instead of using the question mark, I'm going to refer to it as x. So 12 plus x is going to equal 22. Look, it's a basic algebra problem. In order to find x, we subtract 12 from both sides, and we get x equals 10. Now, we want to make sure that this is the correct answer, that we did our math right. So what we can do is ask ourselves, hey, does 10 plus 12 equal 22? It does. 10 plus 12 equals 22, so this missing piece is 10. We've confirmed it. Again, some of you may have been able to figure it out without writing out algebra or writing out an equation. And if you could, that's great. So let's put in our information we know now. It's 10 feet by 8 feet, and the area of a triangle formula is base times height divided by 2. So the base and the height is 8 and 10, which equals 80. And we need to divide that by 2, which ends up equaling 40. So there we have it. The area of this rectangle is 264. We need to subtract 40 from it, and we get an answer of 224 feet square, which is our final answer. So you could have used addition to find this as well. You could have found the area of this square right here and this trapezoid over there, and you could have figured out the dimensions. This is 12 feet by, so square plus trapezoid. This is a 12 by 12. And the trapezoid, the bottom is 12. The top is kind of tricky to find, but we could have used our clue numbers 12 and 8 to figure out that this piece is 4. And the height of the trapezoid was kind of tricky, but we could have used 12 and 22 as our clue numbers to find that our height was 10, and then just find the area and add those up. Let's do our second and final example. In this one, I think addition is actually going to be our better strategy. And I'm going to add the area of this top rectangle, the blue one, with the bottom orange rectangle. So blue plus orange should get us our answer. Let's fill in the information now. Uh-oh, I don't know how wide this rectangle is. It does not say. So what are our clue numbers? We know the whole thing is 13. because it says so down there. So 13 is the whole thing. We also know that this length is 2, and this length is 7, and this length is a mystery length. So if we add 2 plus this number plus 7, we should get 13. So I'm going to set up an equation. 2 plus mystery number, which is x, plus 7 equals 13. Add up your like terms. So 2 plus 7 is 9. So we have x plus 9 over there equals 13. And we need to find our x. What plus 9 equals 13? We can subtract 9 from both sides and find that x is 4. Again, we should check to make sure this is correct. Is 2 plus 4 plus 7 equal 13? 2 plus 4 is 6, plus 7 is, it is 13. So we know this is 4, so I'm going to write that down. 4, and how tall it is, it's not 2. The 2 refers to this, so it is 4 meters tall, so 4 by 4. And the area of a rectangle is base times height, which is 4 times 4, which is 16. Let's do our orange rectangle now. It is not 7 meters wide. It's not 2 meters wide. It is 13 meters wide. So write that 13 down. It's also 7 meters tall. So area of a rectangle is base times height. So 13 times 7 is 91. Now our strategy says we're going to add those two up. So 16 plus 91 equals 107 meters square. So that's our final answer. Again, if you wanted to, you could have used subtraction and found the area of this whole thing first and subtracted this area and that area. And you did have enough information to do that. You could have just said that this is a 13 by 11 using 7 and 4 as your clue numbers. You could have found that this is a 2 by 4. And then this right here is a 4 by 7. So take this area, subtract this area, subtract that area. You would have gotten that same final answer. Anyhow, that is how you find the area of polygons.